Hello guys, welcome to my channel Network Simple, and today I'm going to be talking about wireless infrastructure. What is an infrastructure? What makes a wireless, and what are the components inside the wireless? So this is split into three parts, which is wireless LAN topology. How can you set up a Wi-Fi network? Basically it's the modes of IP. How does an IP find its controller, which means where it receives the configuration and everything, and how do the Wi-Fi signal works. So the first part is going to be, so these are the contents, by the way. This is the another content for third, and this is the third part. So the autonomous are self-sufficient and standalone. It means the AP, the access point does everything by itself, and in the lightweight, the access point is separated. It's delegated. The work is delegated between two components, APs and WLCs. So let's go to the first part. Okay, so this is what the AP is going to be like. It does see. So the access point is like you have two Wi-Fi, okay, two access points, but they will work separately. It will say, hey, if you want to connect, it's just like having a two router inside your home, okay, like one is your neighbor and another is yours. So if you leave your home, when you walk to your neighbors, you have to connect to that. So it's exactly like that. And then this is what it's and then the lightweight split MAC architecture. Now it's like the building. Okay, we have I'm in a building, right? Now my neighbor and me, we're both having the same Wi-Fi. So even if I go to his home, I'm gonna be having my my Wi-Fi still connected to his. It's going to be like, wait, and that will be how, because the building manager decided everyone will be using the one Wi-Fi and no one needs to split it up. So that's what split MAC architecture comes in here. You will have the WLAN controller in which it will do stuff like this, duplicate. So it will duplicate its functionalities to its delegate it to other users. So this is used for having so many APs. And SSID, it means that SSIDs in here, it means you have the what do you say, you see the guest IP guest, and then what home Wi-Fi, guest Wi-Fi. That's what it puts a name out. So it has a different it's a name. SSID means name. Yeah. So you have the lightweight, three types of lightweights. Okay, you have the three types of split MAC architecture, which is WLC and access point, how they work. So the first part is decentralized, where the WLC is directly connected to the core layer, and the access points are of course in the access link. Now the point is that it's there because you have a big range, and the core layer, it will it's easy for the core layer and the access point to be next to each other. And the cap web, I will send you down the full form of the cap web in the down. So don't worry what's the cap web, but it's just a a link connection that, okay, everything I'm receiving any information or I'm updating, I will just go to the to my WLAN controller. My configurations will not be here for the access point, not even in the distribution, not even the core layer. It will, everything will be set it up in here. So you have, now this is the comparison, access point plus switch port. In this you will have management, by the way. In all of the access points you will have a management IP address, and AP switch port runs distribution, does only needs VLAN, does all the separation. WLAN controller is where everything is separated. You configure, modify. So this is like the general architecture on how this access links are working. And then you go ahead with the embedded. Now in the embedded is that, because there is in switch hardware, so in the switch hardware itself you have the WLAN controller, and from the switch it will send to the AP. With user immersed into it, becomes easier to apply command and say notice that it can as well as those located with an access layer. Not call, okay, so I was wrong in the first part, is that the embedded topology can be cost effective because same is used for both wired and Each layers would have its own WLC. So what's happening is that you will have a WLC, okay, directly connected to the switch, and it's just the fact that it's close to the access layer. It becomes more with user access merged into one layer. It becomes easier to apply common access and security policies. So it just become for security purpose. Everything will be the same, even if it goes to the core layer. It's just that the round trip will be less. And embedded shows that traffic, that means wireless can reach each other efficiently. That's it. And for the third part is that the access point itself are the WLC. So it will say, hey, join me. So the access points can now join the access point itself. The same thing. Then we will go to the next part, which is the pairing part, and how the access points connects with the WLC. So access boot, discovery, access point will see what are the WLAN controller available in its network or in the another network, and then it will send an invitation like friend request, and then it will what do you say? The WLC will also say, okay, hey, now you can, well, by the way, I would say this is part is wrong. When it says, when it will join, okay, the WLC will join, the cap web will be formed. And after that, the image will be downloaded, the configuration, the images for that, the access points might not be supported. The WLC, maybe there's an update in the WLC and the access point doesn't have that software. So it will do, it will download the image for it to work with the WLC. And it will then get it will get then the it will then get the what do you say, the configuration. The AP goes to receive to someone. The AP builds Java with one or more controller. That tunnel will provide care for subsequent AP to run extents. When I said the join, both of them should be actually the same thing, same stuff. And then there is another to discover AWS AP sends broadcast messages to its subnet, which is if my AP is under 255, dot 10.10.10.10 2/24, okay, and my WLC is on the next subnet, which is 10.10.20.10 /24. It will say, hey, I don't have WLC on my subnet. I want to join yours. So this will be what's going to be happening, okay. So it will say, once it gets connected, it will say, the WLC will say, hey, I have 3 types of controller. Okay, you can then, and then you can, join one of them. And this is this is what the WLC, in the router, you will configure that, hey, when this IP, when this, what do you say, interface VLAN, when this VLAN, okay, hits me up, tell this VLAN to, he has the access to join to the next network. So it's a configuration to say this VLAN has an access. So if my if my subnet is 10.10. Okay, this is my network. Okay, the WLC is on in here. So I will be adding the interface VLAN. Okay, the what do you say, 200, it will be 20, okay, it will be 2 interface VLAN 2, and then it will I will then add my, no, more like this will be my own VLAN, okay, in which I added my what is it, my access, and then I will be adding the next IP address for it. I will set an example down in the chat, okay, so look into that. And then once there's a selection, it then does do cap wrap and everything. So it will then try to maintain a 30-second key alive interval. And then within this Cisco, in this access points, you will have different types of modes where you can do local, where it will just take the user as it is. Then second is that you will add another access points where you will, there will be a monitor, okay? You will add another access point in which it will, takes dedicate, it will sense any intrusion, it will pick up any wireless signals. Instead of, when you open the wireless signal, okay, when you open the Wi-Fi, it will pick that up, but instead for connecting, it won't be showing in your phone. So this is what these modes are going to do. It's not going to show on your phone, but it's going to be there, and it will pick up that, okay, this device, it will read every devices. Flex Connect, VLAN external to, so what's going to happen instead of Flex, okay, Flex Connect is going to be like, okay, I don't, now the WLAN controller are all down. So it will directly, everything, the access points are going to work independently, like the autonomous mode, and that's it. It will work as an autonomous mode. And the sniffer, it picks up other source of, like if anyone, the software such as where it can, it will sniffer is the another mode in the access point where it will, the when it's in the local mode, it will pick up anything you know how, what are the users that connected to it, and it will read all that packets, where did it went and everything. So rogue detector is rogue devices are that appear both on networks. In AP they do detecting rogue devices, so it will pick up any hotspot. And bridge, it will be like if there's extender, flex plus bridge. So you have an AP, okay, that that AP has what is it called? That AP is now working. Yeah, it's sending everything to the router. Now that then that AP will have an extension, so it will have just double range. And XC Connect, all wireless. Now it will check all these wireless channels. You can remotely connect or Cisco to collect and it will just check the channel. So a lightweight is not in local mode when it's and allowing client data to associate wireless when an AP is configured to operate in a local mode and it is disabled. And then we're gonna be moving to the third part, which is the antennas. How do they work? Okay, so first I want to say, I'm gonna talk about, okay, this diagram. This diagram, it's the perfect. It does everything. Okay, it's the perfect sphere. Okay, we know that what a perfect look like. So this is the perfect signal, and now when now we produce a signal, it's not gonna be perfect, but it's gonna be a comparison. So that's what this radiation pattern is gonna be about. So I want to talk about the terms first, because it's hard to to understand these words. Antenna gains, it means if the signal is low, it will be more sphere-like, but it's but if the the power, if the power of antenna is stronger, it will just go to one direction. And then you have the dBi, which is this. Okay, this is the dBi. And isotropic does not actually, it is ideal. So this is isotropic because it's a perfect sphere. And then the tiny round point, it's the from where the signal is being generated, and electromagnetic waves. And then this when an alternate RF means Wi-Fi radio frequency, but it's Wi-Fi is and the electromagnetic lights are radiated equally. So electricity, the energy produced by the antenna takes the form from an it takes the form of an every. So when the electromagnetic waves are produced, it covers the whole, like magnets, right? So magnets are all curve, and then when you put electric into it, it's all so when you have electric plus magnet, it will have this curve. So plot, you will see the word a plot that shows the related. A plot is the visual. Okay, this is the visual, and radiation showing where the strong or weak radiation is. So in the picture, this, you see the X, Y, Z. Now this, we want to see how an antenna works. Okay, how does it, the signal, how much it covers, which direction. So this is the comparison point will be. And so that was the 80 degree. Both of them will have both this side and this side is covered with the this 360 degree, and you have the XY plane. XY is this, X and Y. See, this is X and Y, then this is X and Z. So up is, it shows up and down. And we have the outermost. You saw the FIFA stats. When you see a FIFA bar, or you see the FIFA, what do you say, the strength, its defense and everything. That's bar chart of that player, it's the same. So yeah, it's the same. Then you have different types of signal. Okay, you have the omnidirectional, it's like yeah, omnidirectional. I don't know what to say. It's just that when you have stronger signal, it's gonna be donut, and you have more stronger signal, it will become direct, more like beam. And then you have the beam width. Okay, if it covers, like it's showing that this is the laser. Okay, imagine laser, imagine light. If you have a strong straight light, it will be able to cover this far. But if it doesn't, it's a width, then you will see that, oh, horizontal. You will be able to see that top. Okay, how what I'm saying is that beam is beam. So just use the analogy of the light bulb. So in here, beam width is like understanding the signal. This is for this part is all about understanding a signal. And then you have the polarization, if the signal is weak or strong, if the electric, okay. So if the electric is good, it will do a lot of up and down. If it's bad, it will just, do, well, you will see that it's very messy. Vertical, horizontal. Okay, the electrical will have the antenna. So if the wire is pointing, it will produce a wave that oscillates up and down. It's called the antenna polarization. An antenna that produce vertical are vertical. The antenna must be matched to the, so it should be matching. If it's horizontal, it's not good. If the mismatch, it's just saying that when I'm receiving the signal, it needs to be, this is how I want to receive the signal. And then you have the omnidirectional. Okay, omnidirectional, it means this, the curve. So what happened is that these are the two wired points. Okay, these are the two electric points. So from here the signal is coming, like from in between it will come, and it will cover the area. So it's put on the top of, by the way, it's installed in the ceiling. And then this is how that antennas are then evolves into, it's all inside it. And then what does this, by the way, this, what it's showing is, what is this showing is that when the signal, this patch antenna gives signal like this. So these are the leaks, by the way. Nothing's still not bad. Then you have another antenna that's giving more directional, like it gave this much direction, right? Now you have, oh, the heavier level of direction. And then you have triple, more stronger directional. So that's what parabolic dish antenna is. Every signal is then concentrated in here. So weak signals are like weak. What does it do is just that if my phone signal is less, okay, it will bounce that signal with high beam. So that's what it does. It converts my small signal to a concentrated signal. And that's how I receive my antennas. Even when I'm, when you're outside, this is how you're connected. You see the satellites, a beam tower, they collect all your signals and just concentrate to another, to the wired network. And that's how, what's the wireless infrastructure all about. Look down in the description. I will be putting up a summary. I hope you understand my lecture, and even if you have some questions, please be sure to ask, and I'm ready to correct if my lecture wasn't explainable or I missed some point. Please comment down in the below, like and subscribe for more content and for the next chapter. Thank you.